this unit because, okay, so we took time to review, remember, and we reviewed two things. We had our trig stuff, which was the sine, cosine, and tangent with SOHCAHTOA. And that helped us find sides of triangles. Remember, we needed to know opposite, adjacent, hypotenuse, that kind of stuff. And then we also did the Pythagorean theorem. Which was a squared plus b squared equals c squared, where a and b are legs of a triangle and c was the hypotenuse. And hopefully we're getting more comfortable with those things because those are the two tools that we really have to find missing side lengths of a triangle. You should use the sine, cosine, tangent, the trig stuff when you have an angle on a side, and you should use the Pythagorean theorem when you have two sides. That way you can find the missing one, or maybe these two sides and you find that missing one. And so where this is going is we want to be able to find the area and perimeter of like some irregular shape. And in order to do that, I think maybe I should just take it slow day by day. Today we'll do area and perimeter of just a triangle. And then tomorrow we can do some other shapes. And then Wednesday we can get back into that thing that I tried to touch on, but I realized that we went a little too fast for, which was finding the area and perimeter of some irregular stuff. So the area of a triangle is just 1/2 base times height. All right, we've seen that before. We've worked with that. If you don't know that, you might want to have it written down somewhere. Now, when I say height, there's a couple different things that I mean. So, you know, if we have a right triangle, which we've been working a lot with, then if this is your base, your height would be here. Right. But if I had maybe a different kind of triangle, maybe if it looked not such like a right triangle, maybe I had my base here, then the height is to the highest point where you make a right angle with the base. So it would be there, right? This would be your height, not here or here, but here. So if you had a triangle maybe like this, your base would be here, right? But your height wouldn't be one of these two, nor would it be something in the middle like that, but it would be from the highest point to where it would have a right angle, maybe if this continued, right? So this would be our height right there. Does that make sense of where the height is on a triangle? And then that's really all we need to find the area. Oh, but hey, maybe it doesn't give us a base and height. Maybe we have to find the base and height using one of these two guys. So let's go over an example. Maybe I have, I'm just going to make it up on the spot. Maybe I have a right triangle. And, let's just say this side is 8. Let's say this side is 15. Okay. And let's say I wanted to find the area and perimeter. Perimeter, you just add up all the sides, right? Well, we need to get used to triangles maybe just not being situated in a way we like, right? If I use this as the base, then my height would have to be that, which is going to be hard to find, right? But if that is my base, then wouldn't this be my height? Right there? Right, if I took this triangle and I just, now it's facing this way, right? Right, if I just, so it makes sense why that's the height. How can I find that height? Oh, I know it's Monday, but we know how to find that height. How can we find that height? Yeah, you have the two sides. So, which one of these? If you have two sides, wouldn't it be the Pythagorean theorem? Don't you use the trig when you have an angle, and the Pythagorean theorem when you have two sides? Yeah. So since we have two sides, we're going to use the Pythagorean theorem. Remember the Pythagorean theorem? A squared plus b squared equals c squared. A and b are the two legs. C is the hypotenuse. So what we really have is h squared. That's one of our legs that we're looking for. Plus the other leg is 8 squared equals the hypotenuse, which is 15 squared. Remember, hypotenuse is always across from the right angle. Okay. Now I want to solve for h. So I'm going to subtract the 8 squared. I'm going to get h equals, and then I'm just going to leave this as 15 squared minus 8 squared. Right, that's what this says, 15 squared minus 8 squared. So I'm just going to leave it as 15 squared minus 8 squared. Oh, and that should be h squared, right? Hey, how do we undo a square? Yeah, square root. To undo a square, you take a square root. Back when we did it, we used to add a plus or minus, but a minus doesn't make sense because we're not going to have a negative side length. So we just take the square root, we get h equals, and this is just something I'm just going to throw into my calculator. I just do the square root of 15 squared minus 8 squared. And I'm going to get about 12.6886. So that means up here that my height is 12.8 or 6886, I think it was. Okay, but our problem is we wanted the area and perimeter. So let's do the area first. The area is 1/2 base times height. Our base is 8, and our height is that 12.6886. And that is also just something we can throw into our calculator. And I get 50, and then usually it wants us to round to a nearest tenth, at least Delta Math does. So if I do If I do 7,544, this is what I get. If I round that, because I think some of us might still have a little issues with rounding. If we round that to the nearest tenth, tenths is this place right here. Right, it goes tenths, hundredths, thousandths, and so on. 0.75, since it's a 5 here, 5 and above, we round up to 8. And instead, since it's an area, whatever units we have will be squared. Okay, that's the area. One last thing, now let's do the perimeter. I'll squeeze the perimeter up here. The perimeter, we just add all the sides up, right? 8 plus 15 plus 12.6886. 8 plus 15 plus 12.68. I get 35.6. And again, if I round to the nearest tenth place, 8's going to round up to 0.7, and then this will just be in units, whatever the units are. Okay, not too bad, right? We could all find the area of a triangle if we use a equals 1/2 base times height. We know what a perimeter is. Perimeter is adding up all the sides. And so, if you have two sides and you're missing the height, find the missing height, right? Which we should have strategies for from the past couple of weeks, Pythagorean theorem or the trig. Any questions on this problem? Okay, let's make one more. Let's say I want to find the area and perimeter again. You know what? Let's make a similar looking triangle. Maybe that's a right triangle there. Maybe I can make this side 9. But maybe now I have that as 40 degrees. If I'm using this as my base, which one of these is going to be my height? Left or right? This one. This one? This one? Absolutely, this would be my height, right? Because that's the vertical one, the tallest point to this that makes a right angle. And then this is just my hypotenuse. Well, I have a base and all I need is my height to do area, so maybe let's do that first. How am I going to find that height? I have an angle on a side. Am I using trig or Pythagorean theorem? I have an angle on a side. Trig or Pythagorean theorem? Trig, right? Pythagorean theorem only involves the sides, but those sine, cosines, and tangents, remember, this x or whatever that came after them was an angle. So if you see an angle, we better be using trig. If we're looking for h, let's focus in on this angle. What is this side? Opposite, adjacent, or hypotenuse? Yeah, this is opposite. What is this side? Adjacent, yes. And this is the hypotenuse. Okay, if we're looking for h, and we know the opposite side, if we're using SOHCAHTOA, which one of those uses opposite and adjacent? Because that's the side we know and the side we want. Yeah, tangent, right? So, tangent uses opposite and adjacent, which is what we have. We have opposite and we want adjacent. So the tangent of the angle, 40 degrees, equals opposite, which is 9, over adjacent, which is our height that we want. Right, and then to solve, we don't like an h in the bottom when we're trying to solve for it, so multiply it over. We get h times the tangent of 40 degrees, 9. Oh, and then remember the tangent of 40 degrees is just a number. And if we have a number times h and we want h by itself, we better just divide by that number. Right, if it was 3h, we would divide by 3. It's basically tangent of 40 degrees times h, so divide by tangent of 40 degrees, and we get h equals 9 divided by the tangent of 40. Make sure I'm in degrees. I am. I get 10.726. All right. Okay, so the area, or maybe I'll do it in a different color. The area, A equals 1/2 base times height. 1/2. The base was 9, and the height we just found was 10.726. And I'm getting 48.267. And then if I round to the nearest tenth, this being the 10th place, six means round up, so 0.3, and then units squared. Oh, hey, if we're still looking for the perimeter, right, we got h as, right, we got h, but to find the perimeter, we're still missing hypotenuse. Now, this is interesting. You can do whatever you'd like. We have two sides now, because we found this one. So we could use the Pythagorean theorem if that's easier to you. I'm going to use trig again because this is rounded, but this isn't. So if I use trig, that's going to give me a more accurate picture. So which one involves opposite and hypotenuse? On SOHCAHTOA, the sine involves opposite and hypotenuse, O and H. So the sine of 40 degrees, the sine of the angle, equals opposite, which was 9, over hypotenuse, which we said was C. I'm going to go a little faster this one. Multiply the C over, divide by the sine of 40. And if we do 9 divided by the sine of 40, we get 14.0. So here we get the hypotenuse is 14. So the perimeter, I'm going to erase these over here. The perimeter is just going to add all these up. So 9 plus 14 plus 10.726. 23, 33.726. Right, and then if we're rounding to the nearest tenth like we usually do, then we'll get 33. 2 means round down, and then whatever units we're in.